Good everyone, my name is Graphics. We are told to differentiate x to the power of y equals to e to the power of x minus y, right? We are told to what? Differentiate. We are told to find the y over what? The x. Now, in this kind of question, you have to see is that since x and y are occurring together, this is an implicit function, right? So we need to differentiate implicitly. So the first thing you have to do is to take the in of both sides, right? So if I apply in of both sides, or we call it natural logarithm of both sides, we'll be having either we have the in of x to the power of y equals to the in of e to the power of what? X minus y, right? Now recall, we know that in a to the power of b, or we say log a to the power of b is equals to what? The power will come behind the log. We'll now be having b log a, right? So if I now apply this into the above expression, we say that instead of writing in x to the power of y, we'll write y in x. The y has come behind the in, equals to what? In e to the power of what? X minus y. I cannot bring x minus 1 because e is not a variable, right? E is not a variable, is an exponential function. So you cannot bring it back of the logarithm. Is that okay now? So you leave it that way. Now, if you look closely, y is multiplying in x, right? So you are going to apply your product rule because when two different variable or two different function are multiplying each other, you apply what is called product rule. Now, there's something I want to show you here. Somewhere in your book, you repeat the same um, expression by writing y in x plus y in x. You see, I'm adding them together because what? It is product rule, right? Now, look at what I'm doing before you write. Just pause, just leave whatever I'm doing and pay attention to what I'm about to do here now. So, equals to in e to the power of x minus y. Now, the first one here, before the plus sign here, if I differentiate only y, I will have 1. I'll differentiate y, I will leave the in x. So differentiate y, I will have 1. Now, since because I'm differentiating y, I must put the y over the x. So I'll multiply, you differentiate y to the power of, because y has a power of what? Of 1. So if I differentiate it, the law says that the power will come in front, which is 1, and I'll subtract 1 from the power. So if I do that, I'll now be having 1 times y to the power of what? 1 minus 1 is 0. I will know y raised to the power 0 is 1, so 1 times 1 is what? Is 1. So, but because it is y I'm differentiating, I'll now multiply the 1 times what? dy over the x. So 1 times dy over the x is what? dy over the x. So my in x is still intact. I did not touch it. Plus, now the other after the plus sign, I will not since I've done y, I'll not do y again. I'll go to in x. Now if I differentiate in x, I'll be having 1 over x. Right? Whenever I differentiate, even though it is in u, it will be 1 over u. In w, 1 over w. So since I'm differentiating in x, I'll be having 1 over x. The y, I did not touch it. So the y will be in bracket. You can see what I just did here is what we call product rule. So before the plus sign, you write the equation, the expression two times. You add them together. You differentiate the first before the sign, before the plus sign. I differentiate the second after the plus sign. So that's what I just did. So equals to, now I want to differentiate in e to the power of x minus 1. Now there's something I want you to understand. You know, I told you just now that if you differentiate in x, you'll be having 1 over x. What do you notice? If I differentiate x, x has the power of what? 1, abi? Now, if I bring the 1, the law says that if I want to differentiate this, I'll bring the 1 to the front. I'll bring the power to the front, which is 1. I'll subtract 1. So I'll be having 1 times x to the power of 1 minus 1, which is what? 0. And into this power 0 is what? Is 1. So it will now be 1 times 1. Because x to the power 0 is 1. So 1 times 1 is 1. So I'm having 1, right? So I'll now put 1 all over what I differentiated. That's how I'm having 1 over x, right? I'm going to apply the same thing in this function here. And I'm going to differentiate the power. I'm going to differentiate ex to the power of minus y, right? So if I differentiate e to the power of y, if I have to differentiate e now, watch now. If I have e to the power of what? Of x, right? Or let me put something you can easily understand. If I have e to the power of what? Of x squared. If I differentiate x squared, I'll be having 2x. Now, if I want to now write my expression now, my answer will now be 2x e to the power of what? S squared. That is how you differentiate exponential function here, right? So if I apply it here now, that means I'm going to differentiate what I have up here and multiply it with what I have. So if I do that, if I have e to the power of what? X minus y. If I differentiate x, I'll have 1 minus, if I differentiate y, I'll be having what I told you earlier to now be 1 because of its y. I'll now put the y over the x. So 1 times the y over the x will give you the y over the x. So I'll now multiply it with the function that I have here, which is what? E to the power of what? X minus y. Now, since there's an in front of it, I'll now divide everything by what is in front of that in, which is what? E x to the power of what? E x power what? X minus y. That's what I just did. That's when you have in x to be 1 over x. In x squared will be 2x over x. In sine will be what? Cos x over what? Sine x. So that's why I just applied here. Is that okay now? Now, if you look closely, e to the power of xy will cancel e to the power of xy, right? I'll be left with what? So if I rewrite my equation now, it will now be the y over the x in x plus y times 1, because this y is like saying y over 1. So the y is like is a numerator on its own. So the numerator times numerator, that means y times 1 will give you y, all over denominator is x, all over x, for x times 1 is also x, right? Now equals to, so if I just equate this here, I'll be having 1 minus dy all over the x. Is that okay? Now I will collect like times. So if I take dy over the x to the other side, right, I'll be having dy over the x ln x plus dy over the x, because when minus dy over the x is coming to the other side, become plus dy over the x, equals to, I have 1 here, 1 is still remaining. After I've taken my negative dy over the x to the other side, 1 is still remaining. So I write that one down. So I will now bring plus y over x. So when it's coming to the other side, it now become minus y all over x, right? So to the next line, if I factorize, I discover that it is only dy. I have dy over the x common in both sides of the sign. So if I bring my dy over the x, I'll be left with what? In x plus 1. So if I expand this, dy over the x times in x will give you dy over the x in x. Dy over the x times 1 will give you what? Dy over the x. So that's what we just did. Equals to, if I look for the LCM of this here, of 1 minus y over x, the LCM is what? Is x, right? And this one like saying 1 in x is x, right? X in x is 1. 1 times y is y. So I'm having x minus y here. Is that okay now? So from here, I'll now make the y all over the x the result of the formula. So that means I'm dividing both sides by what? In x plus 1. So I'm having my x minus y over x multiplied by, if I'm dividing both sides now, it will now be all over what? In x plus 1. So this is my what? My answer. So if you have found this video helpful, please don't forget to click on the subscribe button. Thanks for watching.